Hi students, welcome to physics class. Today we are going to discuss about rigid body. First tell me, what is rigid body? In a rigid body, the distance between different particles does not change. Even the body is in motion. Under the influence of external force, a rigid body executes two kinds of motions. One is translatory motion and another one is rotational motion. Now go for discussion point by point. Definition. In a rigid body, the distance between different particles does not change. Even in motion, even in motion, now under the influence of an external force, under the influence of an external force, a rigid body can execute two kinds of motion. Two kinds of motion. One is translatory motion, second one is rotational motion. One is translatory motion, the second one is rotational motion. rigid body, for a translatory motion, linear momentum is constant. Is constant. In a rigid body, for a rotational motion, the angular momentum is constant. That means if we are applying F external force, on a rigid body, here two are constant. What is that? Translatory motion, Tm. Second one is rotational motion. In the translatory motion, linear momentum that is P is equal constant. In rotatory motion, angular momentum that is L is equal constant. Remember, mass always not equal to 0 because mass cannot be changed. Next, in a rigid body, linear momentum in the bracket P and angular momentum in the bracket L remains constant. With time, for a rigid body, equilibrium, linear acceleration of center of mass would be 0. And angular acceleration also be 0. That means A Cm is equal to 0 and alpha Cm is also 0. Now, translatory equilibrium. Translation equilibrium. Now see, all particles move with the same velocity. That is, the external force acting on the body is 0. That is, sigma F external is equal to 0. The meaning is, that is, sigma F x coordinate 0 comma sigma F y coordinate 0 comma sigma F z coordinate is equal to 0. Since sigma F external is equal to capital M acceleration A external or A center of mass. Since sigma F external is equal to mass into acceleration Cm, center of mass. That means M acceleration center of mass is equal to 0. The reason is since F external is equal to 0, we already discussed. That is M since M not equal to 0. If M not equal to 0 means A Cm is equal to 0. That means ACM is equal to 0 means dV Cm by dt is equal to 0. That implies dV Cm is equal to 0. That means V Cm is equal to 0. That means VCM is equal to 0. That is VCM is equal to constant. Why we are writing 0 is equal to constant? Now go for discussion. If dV center of mass is equal to 0 means V2 minus V1 is equal to 0. If dV is equal to 0 means dV means small change in difference of velocities. V2 minus V1 is equal to 0. That means V2 is equal to V1. Therefore, V1 is equal to V2 is equal to V3 is equal to and so on Vn is equal to V. That means same. That is constant. That is same velocity. Same velocity means constant velocity. Means constant velocity or change of velocity, constant velocity or change of velocity, change of velocity is equal to how much? 0. Therefore, VCM is equal to constant. That is In translation, equilibrium body the velocity either the velocity is either rest, that is v is equal to 0, or uniform velocity, that is v is equal to constant. If v is equal constant, if v is equal to that is v is equal to constant. Okay, that is if v is equal 0, then we call it as static equilibrium. Static equilibrium. If v is equal to constant, then we can call as dynamic equilibrium. If VCM is equal to constant means M not equal to 0, therefore M into VCM is equal to P, that is linear momentum. Linear momentum is constant. This is the meaning for that one. Now we are going to discuss about rotational equilibrium. Now rotational equilibrium. The resultant of torque due to forces acting on the body about any point must be 0. That is sigma torque external is equal to 0. That is sigma torque external is equal to R vector cross force vector external. Therefore, R vector cross force external vector is equal to 0. The reason is sigma torque external is equal to 0. Therefore, force external is equal to 0. Since R not equal to 0, therefore F external is equal to 0 or not equal to 0. Therefore, sigma I is equal to 1, I is equal to N, torque x direction vector is equal to 0, comma, sigma I is equal to 1, I is equal to N, torque y direction J is equal to 0, comma, sigma I is equal to 1, I is equal to N, torque Z K unit vector is equal to 0. Therefore, take a body, it is the radius. This is omega, that is called angular velocity. Which is in anti-clockwise direction. If we apply an external force on this one, it's a linear momentum. Linear momentum, that is L, that is called MVR, is constant. Since F external is equal to 0, Therefore, V external is called constant. Just now we proved this one. Proved. We proved in translatory equilibrium. If F external is equal to 0, V external is equal to constant. Where we proved in the translatory equilibrium. Since R is equal to constant and R not equal to 0 and M is equal to constant. Or M not equal to 0. Therefore, L is equal to MVR. That is equal, that implies L is equal to constant. That means if we apply a force on a body, take a particle here, take a particle, if it is in rotation motion, it will be rotate like this. Example, if a particle is rotating like this, in this case, 2 points we have to remember. It is moved from A to B. The particle is moved from A to B in this direction. Therefore, here the particle from one point to another point will be acquired translatory motion. In the translatory motion, P is equal to constant. That means linear momentum is constant. Now, in rotatory motion, take particle here, the same. It is moved from, consider A to B. A to B. In this case, particle is here. It is moving, consider in anti-clockwise direction or clockwise direction. To make you understand, take like this. It is moving like this. That means rotatory motion L is equal to constant. That means angular momentum is constant. Okay, this is about A rigid body, and it has two motions. One is translatory motion, second one is rotational motion. How? Which physical quantities are constant? In the translatory motion, P is constant. In the rotational motion, L is constant. P means linear velocity, L means P means linear momentum, L means angular momentum. This is about rigid body. This is important concept. I hope you understood this video. Thank you very much for watching this video.